So the first chapter we're going to do in 20-3 is on trigonometry. The ideas that we're going to use are the same ideas that you would have learned in 10C and 10-3 regarding the three primary trig ratios, which are sine, cosine, and tangent. These three trig ratios you're going to have with you on a formula sheet, so you don't need to necessarily memorize them. However, it is helpful as you use them further. We're also going to continue with the idea of Pythagorean theorem, a squared plus b squared equals c squared, which works only for right-angled triangles. So we're going to start with a review of how do we figure out which sides are our hypotenuse, opposite, and adjacent. So our hypotenuse, this side is always opposite to the 90-degree on the triangle. It is also the longest side on the triangle. Okay, the 90 degrees is the largest angle, so the opposite to it will have the largest side. That is always the hypotenuse, that doesn't change. The opposite and adjacent sides do change depending on which angle we're looking from. So if I look from this angle here, theta, the adjacent side is the side that is right next to that angle. Okay, so it's going to be touching it. So the side that connects adjacent is going to help form the triangle. My opposite side is the side that is directly across from the angle. So this side does not have a piece of that angle. It's the opposite. My other two sides, the hypotenuse and my adjacent side, make up the angle. So the opposite is the one that's across from the angle and adjacent is next to it. So if I were to look and instead look at this angle here, and I wanted to know which sides were which, this side across from this one would be opposite, and this side here would be adjacent. So it depends from what angle we're looking at. The opposite and adjacent sides are going to change. So we have to be mindful of that. Sometimes students will get ahead and decide that they want to label the opposite and adjacent ahead of time. However, it really depends on which angle we're looking for. So it is easier to do that once we know what we're looking at. Okay, so the first couple examples here, we're going to solve the following triangles. And if we're solving a triangle, that means we're looking for all the missing pieces. So if I look here, I'm missing this side length as well as these two angles. So I need to find both of those, or all three of those. So I'm going to start by finding an angle first. So I'm going to start and find angle A here. So this is labeled A, so that means that this side is, or this angle is angle A. So I'm going to start by looking at the pieces of information that I'm already given. So if I'm looking from this side length, I have this side, and I know now what angle I'm looking from. If I look here, this angle, if I look across, this is my opposite side. So it's okay here to label that this is the opposite because I'm looking at the specific angle. That means this one that is making, this line is making a part of that angle. This is going to be my adjacent. Okay, so if I want to figure out the angle, I need to look and figure out, okay, I have opposite and adjacent, so I'm going to look at my three trig ratios, opposite and adjacent. That means I'm going to look for tan. Okay, so tan of angle A is equal to opposite over adjacent. Okay, now my opposite side, let's substitute this in. So tan of A is equal to 7.5 over 15.3. Now, whenever you're looking for an angle on your calculator, you're going to use inverse. So I'm just going to grab my calculator here, and so that you can see both things at once. So I'm going to go second, and I'm actually going to make sure I'm in the right mode because that will change us here. So I'm going to go second, and I want tan. So on your calculator, you'll see tan to the -1. That means we're working with inverse tan, and that's what I want to have here whenever I'm looking for an angle. So then that means that this angle A here is, we're gonna say 26 degrees. We're gonna round it to the nearest whole. So that's a piece of the triangle I need to know. So this is 26. I also want this angle B here, and I can go and do tan of angle B as well. Or the other thing that we're going to know about triangles is that a triangle add to 180 degrees, all the angles in them. So this angle here is 90 degrees, and that's denoted by that little square there. We know that the other one we just solved for is 26. So I know that if I take 180 minus 90 minus 26, I will get my other angle. So I'm gonna go 180 minus 90 minus 26, and my other angle then is 64. So B is equal to 64 degrees. Okay, so we have my two angles. The last piece I'm looking for is this H. And there's a couple different ways you could solve for that. You could use a trig ratio now that you know an angle, but most often students like to use Pythagorean theorem. So I have two side lengths and I'm looking for my hypotenuse. So I'm going to use a squared plus b squared equals c squared. So my a, 7.5 squared plus 15.3 squared equals c squared. So we're going to type that in, 7.5 squared plus 15.3 squared. And now this is not my final answer. It gives me c squared. So what I actually need to do is to take the square root of this number. So I'll get 17. So c equals 17 centimeters. And a good check for this is my hypotenuse, this side here, should be the longest side. So if I look at the other two side lengths, 7.5 and 15.3, they're shorter than 17, which makes sense. If I got a side that was shorter than the other two, I've probably made a mistake somewhere. Okay, let's try our next one here. So now I'm looking, I need S, side S, angle T, and angle S. And really, I could start with whatever I would like to. I'm going to start with the angles. So I'm going to look at angle S first. So if I look here, this 9.3, this is my hypotenuse. Okay, I know that it's opposite to the 90, it's my longest side, that's my hypotenuse. Now this 4.3, this side length is connected to the angle. It's right next to it. This is my adjacent side. Okay, so if I'm looking at hypotenuse and adjacent, we can refer back up here, and I'm going to want to use cosine. So I can take cosine of, I'll write down S, is adjacent over hypotenuse. So cos of S is equal to 4.3 over 9.3. Okay, and whenever we're looking for an angle, I need to take second of that trig ratio. So you'll see where it says a -1. So 4.3 divided by 9.3. If I can type it in correctly. We're struggling. Okay. So I'd say we could round this to like 62.5 or 63 degrees. Let's go 63. We'll round it to a nice even whole. Okay, so that means that this here is 63 degrees. Now, to figure out angle T, all I'm going to do is take 180 minus the angles that I know, because I know that all the angles in a triangle have to add up to 180. So I know that one of them is 90, and I know that the one that I just found is 63. So 180 minus 90 minus 63 is 27. So the last angle that I'm looking for, angle T, is 27 degrees. And you know what, I'm gonna box these to state that these are our answers. This is T. And then the last thing we need to find is this side S. So to get S, I'm going to use Pythagorean theorem again. However, I want you to note that I already have the hypotenuse. So when I look at a squared plus b squared equals c squared, I'm actually looking for either a or b. It doesn't really matter which one, but I already have the hypotenuse. So I'm going to say a squared plus 4.3 squared equals 9.3 squared. So if I rearrange this and I subtract the 4.3 from both sides, I'm going to take 9.3 squared minus 4.3 squared will give me a squared. So 9.3 squared minus 4.3 squared. And remember, we have to take the square root of that answer. So my answer is going to be, and we'll go to the nearest tenth, so 8.2. And this will be side S. Okay. So let's look at the following examples here. How many examples do we have? Okay. We have 7 examples we're going to go through, and they're all using the ideas that we just reviewed. So in this one here, I'm looking for what side X is going to be. If I'm looking, X is in this triangle here, and every single triangle I'm going to solve needs to be a right angle triangle. So I know that I have a right angle here, which means I have a right angle here. So I only have the side length over here, so that's not helpful yet. However, maybe I could figure out this side length that both the triangles share. If I look, I have an angle. I have this side, which is 19 centimeters long. If I think about it, in reference to this angle that I have, this is going to be my adjacent side. Now, I want this side, that is this middle piece, and I'll highlight that so you can see what we're talking about. I want that side, which is going to be my opposite side. It is across from the angle I'm working with, but it is not across from the 90 degree. So I'm looking with opposite and adjacent. So in order to find my opposite side, I have opposite and adjacent, I can use tan. Tan of 35 degrees is my opposite side over my adjacent side, which is 19. Now, one of the things you can do here is we can put tan of 35 over 1 so that we could easily cross multiply. So if you draw a little fish in there and you follow, I'm going to take 19 times tan of 35 divided by 1 will give me my answer. So let's follow that, and we're going to take 19 times tan of 35 and divided by 1 is going to give me the same thing. So that means that my opposite side is 13.3. So my opposite equals 13.3 centimeters. And I'm just going to change that out here. Okay. Now the last piece that I'm looking for is this side length here. So in this triangle, I don't have an angle. So I cannot use my primary trig ratios. But I do have 2 sides, so I could use Pythagorean theorem to figure out my third side. Okay, my third side here, this x, is my hypotenuse. It's opposite to the 90 degree. So all I need to substitute in is 13.3 squared plus 33 squared equals c squared. Okay, so then from there, we are going to solve in our calculator. So I'm going to take 13.3 squared plus 33 squared. And remember, that's not my number. I need to take a square root of it. So my final answer there is going to be 35, and let's go to the nearest tenth, so 35.6. And that'll be what x is, which is what the question is asking for. Okay, let's look at our next one here. It says to find our indicated side lengths. So anytime it says that, what it means is what is labeled as a variable. So x and y are both the pieces of information that I want here. So if I start looking here, this y is a part of this bigger triangle. So I might not be able to find it yet because this 6.3 is a part of this smaller one, and I would need this whole side to get the y. However, I can probably find this x. If I look, I have this angle that is 28 degrees. This side length here, the 6.3, is my adjacent side to that 28 degrees. And then this x is my hypotenuse. Okay, so I want my hypotenuse, I have adjacent. If we look at our formula sheet and we try to figure out, okay, what pieces of information do I have, you should hopefully figure out that you can use cosine. So cosine of 28 degrees is equal to 6.3 over x, which is my hypotenuse. So now I'm going to put this over 1, and we can cross multiply. So I'm going to take 6.3 times 1 divided by cos of 28. So 6.3 times 1 divided by cos of 28. So my answer is going to be 7.1. So x equals 7.1. So I'm going to write that here. So if I look, that means that this entire side length here is going to be 7.9 centimeters because I'm going to add on this 0.8. Okay? Now, if I look at what's left, I have my hypotenuse side, I have an angle, and I'm actually looking for y, which in this case is my opposite. Okay, and this is my hypotenuse. So we have to decide, what am I going to use here? I have opposite and I have hypotenuse. So we want to use sine. So sine, in this case of 28 degrees, is opposite, which is labeled y, over my hypotenuse, which is 7.9. Okay, I'm going to put this over 1, and we can do cross multiply. So I'm going to take 7.9 times sine of 28 divided by 1. So I'll start with 7.9 times sine of 28. And if I divide this by 1, I'm going to get the same answer. So 3.7 is my answer here. So y is equal to 3.7. I'm looking for both x and y in this case. I'm going to box both of my answers here. Okay. Our next practice question is this one here. So if you notice, there are no right angle triangles here. However, it does show me that I have two side lengths that are the same. So I'm going to draw a straight line down here. Okay. And what I know about that is that this side length and this side length are also going to be the same. Okay, so that means that this is also 6. And then I have an angle here. So this question is asking us to calculate the dimensions of the plywood. So I know that each piece of this square is 6, but I'm going to need to figure out, okay, what is this side length as well as what is this side length? Okay, the nice thing here is that I have an angle and my opposite side to that angle already. So I can use my trig ratios. Okay, so if I'm looking from this 68, this goes across. This is my opposite side. So really, now we have to pick what we want to solve for first. I'm going to start by looking for this angle, or not this angle, this side length here. So that would be my hypotenuse in this case. So I have opposite and I have hypotenuse. So I can use sine, because sine of theta equals opposite over hypotenuse. So sine of 68 degrees equals 6 over my hypotenuse. Now, I'm going to put this over 1 so I can do some cross multiplication. Okay, so I'm going to go 6 times 1 divided by sine of 68. So 6 times 1 divided by sine of 68. So I'll get 6.5, we'll round to. So the hypotenuse is 6.5. And I'm not quite sure what unit we're in. We're in feet. Okay, so that means right here, this is 6.5. Now, the last piece of information that I'm looking for is this last little side length here. So you could use Pythagorean theorem here to calculate that using a squared plus b squared equals c squared. To get some practice in, I'm going to use the trig ratios. So if I'm looking for this side length here, I'm looking for, this is my adjacent, and I'm going to use the 6 again, which is my opposite. So I'm going to use tan is opposite over adjacent. So tan of 68 equals 6 over x. Okay, so to calculate this, I'm going to go 6 times 1 divided by sine of 60, or tan of 68. So 6 times 1 divided by tan of 68. That's going to be 2.4. So x equals 2.4 feet. So then my dimensions of the plywood are going to be 6 by 6 by 6.5 by, on the bottom here I have a 6 plus the 2.4 that's here, so that's going to be 8.4. So those are the dimensions of my plywood there. Okay, let's continue. So a woman is standing on one side of a deep ravine. The angle of depression to the bottom of the far side of the ravine is 52 degrees, and the ravine is 120 meters across. How deep is the ravine? So I've included this graphic here. So angle of depression means that we're going from a horizontal and it's the horizontal down. Okay, angle of elevation is like if you're looking up, angle of depression is going down. So if I were to draw this, so her angle of depression, so if I look here, her angle of depression will be here, okay? And that's 52 degrees. And it says that the ravine is 120 meters across. So imagine that we have a ravine here. So it is 120 meters across. So I could write it down here, or I can also know that it's going to be the same up here. And then it asks us, how deep is this ravine? So I want its height. Okay, so my angle of depression, one of the things you can know is that our angle of depression is the same as our angle of elevation. Okay, so if I were to draw this and like this, and I'll erase this in just a second. Okay, my angle of elevation would be right here because it's from my horizontal up. That's going to be the same here, which you would have learned last year if you took 10-3, that is a Z angle. I have two parallel lines, so we can see that the angle of depression is the same as the angle of elevation, just in a different spot. So now we want that height. So let's look here. This 120 is next to the angle that I have. This is going to be my adjacent. The height is my opposite side. So opposite and adjacent, I'm going to use tan. And if I write it out generally. Okay, so tan of 52 degrees equals opposite over adjacent, and I can solve for h and put that over 1. I'm going to go 120 times tan of 52 divided by 1. And divided by 1 would give me the same thing. The height is 154 meters. Okay, we're almost there, I think. Okay. So Ethan buys a portable conveyor for stockpiling and landscaping materials such that his gravel in his maintenance yard. The conveyor has a length of 12 meters and makes a maximum of an angle of 15 degrees with the ground. So we're going to sketch this out. So if I have a conveyor belt, it's saying that the belt is 12 meters long, and it's saying that this maximum angle is 15 degrees. Okay, so that means that that's as high as it can go. So B is asking for the maximum height. So we're looking for this here, this height. So if I want that maximum height, that is going to be my opposite to the angle that's given. And this is going to be my hypotenuse, the 12. And this is going to 90 degrees. So opposite and hypotenuse, I can use sine to figure out what that opposite is. So I'm going to take 12 times sine of 15 divided by 1. So the maximum height is going to be 3.1 feet, or 3.1 meters. Okay. And then it says the gravel stockpile is in the shape of a cone and makes an angle of 37 degrees with the ground. What volume of the material can Ethan store in the stockpile? So we're going to draw this out. However, right now we're not going to calculate this because at this point we haven't actually done surface area and volume, so I won't worry about it right now. However, this question, what it's saying is that the angle with the ground, this would be 37 degrees here. Okay. Okay. Example 6. Miranda is installing a pipe with a bend in it. The first part of the pipe is 6.2 meters long and makes an angle of 18 degrees below the horizontal. So that's talking about right here. The second part of the pipe is 3.4 meters long and makes a 42-degree angle below the horizontal. How many meters below the horizontal is the end of the pipe? So it's asking from the start of here to here, how far did we drop? So we are shown drop 1 and drop 2. So if I want the total that it's dropped, I need to calculate both drop 1 and drop 2. So this question's set up so that they're going to be the same calculation. However, we're going to have to change our numbers up a little bit. So if I look, I have 18 degrees here. This is my hypotenuse, and this is my opposite. So I'm going to use sine of 18 degrees equals, I'm going to say x1 over 6.2. So we'll be able to figure out my drop 1. And we are going to take 6.2 times sine of 18, and we'll get a drop of 1.9. So this is what I'm calling x1 here. I'll call this x2. So then I'm going to do the same thing to figure out drop 2. I have my hypotenuse, I have the angle, and I'm looking for the opposite here. So I'm going to take sine of 42 degrees equals my opposite, which I said is x2, over 3.4. So I can write in the 1 there if that's helpful. So we're going to go 3.4 times sine of 42. So that's going to be 2.3. So if I want my total drop, I'm going to take 1.9 plus 2.3, and I should end up with, I think, 4.2. Okay, so my total drop is 4.2 meters. Okay, my next question is, it says a roller coaster at an amusement park heads upwards at an angle of elevation of 40 degrees, that's shown here, for 50 meters along the slope, and then drops back down to ground level over a horizontal of 30 meters. What is the angle of descent indicated by x? So we're looking for this angle here. So in order to get that angle, I'm going to need one other piece of information for the triangle that's here on this right side. Okay, so to do that, the only piece of information that is shared between these two triangles is this side length. So let's figure that out. So I'm given the angle. This 50 meters is my hypotenuse, and this blue line that I've colored is going to be my opposite. And I'm going to call it y, just to give it a variable. So if I'm looking at opposite and hypotenuse, I'm going to use sine is opposite over hypotenuse. So sine of 40 degrees equals y over 50. Okay, so I'm going to take 50 times sine of 40. Which is going to be 32.1. And that's going to be in meters. Now, that's not my final answer. All that is that this is 32.1 meters. So in order to get this angle, I am going to have to figure that out. So I'm given this 30 meters, which is my adjacent, and this 32.1, which is going to be my opposite in this triangle. So opposite and adjacent, I'm going to use 10. And in this case, they've said that the angle is called x. So opposite is 32.1, my adjacent is 30. And now whenever I'm looking for an angle, I have to use inverse, okay, or second 10. which is going to be 32.1 divided by 30. So the angle is going to be, we'll round it to the nearest whole, of 47 degrees. So x equals 47 degrees. Okay, so that is 4.1, the first section we're looking at. There are a lot of practice questions that go along with each of the questions that we've done today. So I would recommend going and doing some of those practice questions, checking your answers on Google Classroom. I've posted the solutions so you can check them. And then you will also have an assignment for all of chapter 4. So make sure you do 4.2 as well and then do your assignment. They are separated into sections, so if you would like to start on 4.1, you can. And then come back for the video for 4.2 and we'll go over those examples. One thing I would suggest, make sure that you have a good scientific calculator, not just a basic calculator, not just your phone to be doing this with, to make sure that you're doing the calculations properly. Let me know if you have any questions.